Alright, Algebra 1, Operations in Scientific Notation. These are the type of problems we'll be working on today. Before we go over these problems and solve these problems, there's a few concepts we need to go over. Okay, one of the first ideas that we have here, or first concepts that we have, and so let's say we have a number. Okay, 3 times 10 squared. Okay, everybody knows that 10 squared is 10 times 10. Okay, that equals 100. So basically we have 3 times 100. Okay, that gives us 300. Now notice that basically what we're doing is we have a number here, 3. So we could represent it as 3.0. Okay, when I take this number 3.0 and I multiply it by 10 squared, what I'm doing is I'm moving the decimal place this many times. Okay, here's the exponent, 10 to the second power. So I'm moving the decimal place 1, 2 places over and then filling it in. That's where we get this number 300. Okay, let's go over another example, just a quick concept review. So let's say we have 4.5 times 10 to the third power. Okay, remember 10 to the third power is 10 times 10 times 10. Okay, that equals 1,000. So basically we have 4.5 times 1,000. Okay, what I'm going to do with this number, 4.5, is I'm going to look at this exponent. Okay, we're multiplying it times 10 to the third power. Okay, that means I'm going to move this decimal to the right 1, 2, 3 times. And then fill it in with zeros. So we get this number 4,500. Okay, we're just moving the decimal place over 3 times because we have this number to the third power. Okay, so what that means is that if you have a number, let's say you have a number 4, 5, 1, 2, 3 zeros. Okay, let's say we have this number 45,000. Okay, you could kind of represent it as this 45,000, 0.0. Okay, this still remains 45,000. Okay, if I want to put this in a scientific notation, what I need to do is I need to get the decimal in between these two numbers here. Okay, basically the decimal needs to be placed here. So there's just one number and a decimal followed by everything else. So when I move this decimal to the left, 1, 2, 3, 4 times, okay, that means that I have 4.5 times 10 to the fourth power. Okay, simply moving the decimal to the left. Because remember, when I have 4.5 times 10 to the fourth power, 4.5 times 10 to the fourth power, that means I'm going to go 1, 2, 3, 4. I'm going to move that decimal over 4 places. Okay, that gives me back that number, 45,000. So if I have 45,000, I could represent that by taking this decimal, 1, 2, 3, 4. Now I have 4.5 times 10 to the fourth power. Okay, so once again, let's just say I have a number 5.72 times 10. Let's take to the fifth power, times 10 to the fifth power. Okay, I'm going to take that number 5.72 and I'm going to move that decimal to the right 5 times. 1, 2, 3, 4, 5. Okay, there's where the new decimal ends up. So we get this number 572,000. Okay, now if I want to take this number 572,000 and I want to put it back into scientific notation, I need to take this decimal and move it to the left. 1, 2, 3, 4, 5. So now I have 5.7 times 10 to the fifth power. Okay, so let's just take a number. Let's take a number. How about 262 followed by a couple zeros here? Okay, I want to take this number and put it into scientific notation. Okay, remember, here's the decimal at the very end. So I'm going to count how many times I move it to the left. Okay, 1, 2, 3, 4, 5, 6, 7 times. So I have 2.62 times 10 to the 7th power. Okay, this number is represented in scientific notation as 2.62 times 10 to the 7th power. Okay, one more example of this, and then we'll do some negative exponents. So one more example, let's say we have 7.623 times 10 to the fourth. So I'm going to take this number 7.623 and move it over to the right 4 times. 1, 2, 3, 4. Okay, there goes my 0. So this number is equal to this number here, okay, in scientific notation. So what that means is if I have a big number and I'm trying to convert it, or let's say I have, not even a big number, let's say I have 13.2, and I want to take 13.2 and represent this as scientific notation. Okay, that means I need to take this decimal, place it in between these two numbers here. So I have 1.32 times 10 to the first power, because I just moved it over once. Remember, in scientific notation, you have one number, okay, and then it's followed by this decimal point. So basically, you're trying to aim to get the decimal point in between the first two numbers here. Okay, one more time. If I have a big number, let's say 3, 4, 2, 5, 0, 0, 0, and I want to convert this to scientific notation, you note that the decimal is at the very end here. Okay, we're going to count 1, 2, 3, 4, 5, 6. So we have 3.425 times 10 to the 6th power. Okay, this is how you represent this number here. Okay, this number that we had here without all this mess here, this number represented in scientific notation, okay, gives us this 3.425 times 10 to the 6th. Now what happens when you have a negative exponent? So let's say we have 4.23 times 10 to the negative third power. Okay, then I'm going to be moving it to the left here. So 1, 2, 3. Fill it in with 0. So we have 0.00423. Okay, so 4.23 times 10 to the negative third, that equals this number here. Okay, once again, let's say we have a number here. Let's say, 5.72 times 10 to the negative 2. Okay, I'm simply going to move this decimal to the left. 1, 2. So we have 0.0572. Okay, 5.72 times 10 to the negative 2 equals this number here. All right, so what that means is if you have a decimal number, let's say you have 0.00062, and I want to represent this in scientific notation, I'm going to count. Okay, I'm going to move it to the right. So 1, 2, 3, 4. Okay, so it's 6.2 times 10 to the negative fourth. Okay, this is how it's going to work. So now we could get to work kind of working on these problems if you understand this concept about moving decimal to the left and to the right. Okay, if the decimal goes to the right, okay, the exponent is going to decrease. If the decimal goes to the left, the exponent is going to increase. Okay, one other concept that you need to know is that if I have 10 squared times 10 to the 6th, okay, that you're going to add those exponents. So that's basically 10 to the 2 plus 6. That equals 10 to the 8th power. So 10 squared times 10 to the 6th equals 10 to the 8th power. Okay, this is your algebraic identity, that if you have the same base, let's say base A raised to the B times base A raised to the C, that equals base A raised to the B plus C. Okay, this is an algebraic identity. So once again, let's say you have 10 cubed times 10 cubed. That's going to equal 10 to the 3 plus 3. That equals 10 to the 6th power. Alright, same thing with negative numbers. So if I have 10 to the negative 4th times 10 to the negative 2, that's going to equal 10 to the negative 4 plus negative 2. That equals 10 to the negative 6th. Okay, you're simply going to add these exponents together. Okay, also if we have mismatching, so if I have one positive and one negative, so 10 cubed times 10 to the negative 4. Okay, we're going to add 10 to the 3 plus negative 4. Okay, 3 plus negative 4 is negative 1, so that's going to be 10 to the negative 1. Okay, simply adding these exponents together. Okay, so what happens when you have these two scientific notations that are being multiplied together? Okay, what you're going to do is you're going to take these numbers here, 2 and 3. Okay, we're going to ignore this for right now. We're just going to take 2 and 3. Okay, we're going to multiply those together. 2 times 3 equals 6. Okay, so we have this number 6. Okay, now we're going to take the powers of 10. So we have 10 to the 4th times 10 cubed. That equals 10 to the 4 plus 3. That equals 10 to the 7th power. So we have 6 times 10 to the 7th power. Here's our answer. Okay, what if we have something like 3 times 10 to the negative 5 times 3 times 10 cubed? Okay, first thing we're going to do, multiply the numbers here. 3 times 3. 3 times 3 gives us 9. Okay, times 10 to the negative 5 plus 3. So we get 9 times 10. Negative 5 plus 3 gives us negative 2. So we get 9 times 10 to the negative 2nd power. Remember, we're just multiplying these two numbers here together to get our number, and then we're going to take the base. Since it's the same base, we could add the exponents. So we do this first, and then we're going to basically multiply these together, which means adding the exponents. Okay, here's another one. So let's say we have 5 times 10 to the negative 5 times 6 times 10 to the negative 3. Okay, we're going to multiply these single digits here first. So 5 times 6. 5 times 6 gives us 30. Okay, times 10 to the negative 5 plus negative 3. So we have 30 times 10 to the negative 8th power. Okay, this is the answer that we get. But remember that in scientific notation, I need to get the decimal here. Okay, I want just a single number. Okay, 30, that's too big, so we need to have it 3. 3 times something. Remember, when we're moving it to the left, we have to add, this increases. Okay, so I'm now going to have 3 times 10 to the negative 8 plus 1. Okay, remember, when I move this decimal this way, when I move it to the left, I'm increasing it. So there's that plus 1. Okay, so what we get is, for our answer, we get 3 times 10 to the negative 7th. Alright, now let's go over some of the problems that I posted earlier, some of the probably what you'd consider more difficult problems. Okay, here's the first one here. We have 1.08 times 10 to the negative 3rd times 9.3 times 10 to the negative 3rd. Remember, first thing we're going to do is we're going to take these numbers here and multiply them together. So we have 1.08 times 9.3. Okay, easy way to do this if you don't have a calculator is to back these decimals out. So we have 1, 2, 3. Okay, remember that I backed those decimals out 3 places. So now I have 108 times 93. Okay, 108 times 93. So using our vertically and crosswise, 3 times 8. 3 times 8 gives us 24. So big 4, carry a 2. Crosswise, 3 times 0 plus 9 times 8. That's 0 plus 72. 0 plus 72 is 72. So we write a 2, carry a 7. Now I have 3 times 1 plus 0 times 9. So 3 plus 0 is 3. And then finally, 9 times 1. 9 times 1 is 9. Okay, doing our carries. Starting at the right, we have 4. 2 and 2 gives us 4. 3 and 7 gives us 10, so we write a 0, carry a 1. And 1 and 9 is 10. Okay, so this is what we get when we multiply 108 times 93. Now remember that we backed this decimal out 3 places. 1, 2, 3. So we need to take this decimal back in 3 places. So 1, 2, 3. So 1.08 times 9.3, that equals 10.044. Okay, that's what we get when we multiply 1.08 times 9.3. We get 10.044. Okay, so that's this portion of it. Now we need to multiply these 10 powers of 10 together. So just erasing some of this work that we have here. Okay, we're going to keep this number 10.044. Okay, so we have 10 to the negative third times 10 to the negative third. Okay, that equals 10 to the negative 3 plus negative 3. That equals 10 to the negative 6th. Okay, when I multiply this and this, I get 10 to the negative 6th power. So what we have is 10.044 times 10 to the negative 6th power. But remember, scientific notation, I need to get this decimal here. Remember, the goal is to get that decimal between the first 2 digits here. Okay, you see here, 1, there's a single digit and then followed by a decimal. Single digit followed by a decimal. So we need to kind of keep this. This is your scientific notation. I need to move this decimal over to the left. Okay, just by 1. When I do that, it increases this exponent. So now I have 1.0044 times 10 to the negative 6 plus 1. Negative 6 plus 1 is negative 5. So here's our answer. 1.0044 times 10 to the negative 5th power. All right, our next problem. 2 times 10 to the negative 4th times 8.1 times 10 to the negative 1st power. Okay, once again, we want to take these numbers here, multiply those together first. So we have 8.1 times 2. Okay, easy way to do this is just back this decimal. Okay, we backed it out by 1. So now we have 81 times 2. Okay, 81 times 2 gives us 162. But because I backed that decimal out 1 place, I need to back it back in 1 place. Okay, I backed it out 1. Now I need to back it back in. So we have 8.1 times 2 gives us 16.2. Okay, that's our first part of our answer, 16.2. Okay, now we need to do this powers of 10. So 10 to the negative 4th times 10 to the negative 1. So 10 to the negative 4th times 10 to the negative 1. Okay, that equals 10 to the negative 4th plus negative 1. That equals 10 to the negative 5th power. All right. So now we have this number 16.2. 16.2 times 10 to the negative 5th power. But once again, we're doing scientific notation, which means that I need to get this decimal. I need to get this decimal in between the first 2 numbers here. So if I move it to the left by 1, okay, now I have 1.62. That means I need to add 1 here. So I have 1.62 times 10. Negative 5 plus 1 gives a negative 4. Okay, here's our answer. 1.62 times 10 to the negative 4th power. All right, last problem. We have 3.48 times 10 to the 3rd power times 9.8 times 10 to the 4th power. Okay, first thing we need to do is multiply this portion of it. So we have 3.48 times 9.8. Okay, if you don't have a calculator, what you could do is back this out. 1, 2, 3. So we have 348 times 98. Okay, doing our vertically and crosswise, here we have 8 times 8 gives us 64, so we write a big 4, carry 6. Then we have 4 times 8 plus 9 times 8, so 32 plus 72 gives us 104. So write a big 4, carry 10, that's our 104. Next we have 8 times 3 plus 4 times 9. So we have 24 plus 36. 24 plus 36 gives us 60. So we write a big 0, carry 6. And finally we have our 9 times 3. 9 times 3 gives us 27. Okay, doing our carries this way. Starting at the right, we have a 4. Okay, 4 and 6 gives us 10, so we write a 0, carry a 1. 10 and 1 gives us 11, so we write a 1, carry a 1. Okay, then we have 27 and 7. 27 and 7 gives us 34. So remember that we back this out 3 places. 1, 2, 3. Okay, 1, 2, 3. So we need to back it back in. 1, 2, 3. Okay, backing it back in. 1, 2, 3. So we have 34.104. Okay, when I multiply 3.48 times 9.8, I get 34.104. Okay, next thing we need to do is we need to multiply these powers of 10. So we have 10 to the 3rd power times 10 to the 4th. Okay, that equals 10 to the 3 plus 4. That equals 10 to the 7th power. Okay, remember, we're just adding the exponents. 10 to the 3rd times 10 to the 4th equals 10 to the 3 plus 4. That's 10 to the 7th power. Okay, so we have 34.104 times 10 to the 7th power. Okay, but once again, we need to get this decimal, we need to place it here. So we need to kind of move it over to the left once. Okay, moving it over to the left means we need to add 1 here. So our answer, we have 3.4104 times 10 to the 8th power. And here's our answer. Alright, I hope you enjoyed this video on how to multiply in scientific notation. If you enjoy these type of videos, hit the like button, leave a comment down below, and subscribe to my channel for more videos. Thank you.